So this section relies on the Pythagorean identity. So this is something that's been proven true when we're looking at the unit circle. If I take my sine value and I square it, and then I take my cosine value and I square it, that always equals 1 every time. So the way we write our notation though, instead of doing sine theta squared, we write it sine squared theta, but these are equivalent. That means they're the same, it's just a notation. So cosine squared theta, this is the Pythagorean identity. And we're going to use that because we're given cosine and we need to find cotangent. So remember, our x value is our cosine value, our y value is our sine value, and this is asking for cotangent, which is, remember, tangent is y over x. So cotangent is x over y, or cosine over sine. So we already have the cosine value. We're going to find the sine value and then get the cotangent. So let's start with our identity. Sine squared plus cosine squared. Our cosine is -7/8 equals 1. And we want to get sine squared by itself. So we're going to subtract this value on both sides. So now I just have sine squared theta equals, and I'm going to put that in the calculator. So 1 minus 7/8 squared is 15 over 64. But I don't want sine squared, I just want sine. So I'm going to take the square root of both sides. So now I just have sine theta, which I need to go down here. And I'm going to split this square root because I know that the square root of 64 is 8. That's a perfect square. So now I have a sine value and a cosine value that are going to go in for cotangent. So cotangent is cosine over sine. Well, cosine is -7/8 divided by sine of square root of 15 over 8. So when you divide fractions, you multiply by the reciprocal, right? You take the numerator, copy, dot, remember that, and then the bottom reciprocal. So here, my 8's cancel out, and I have -7 over the square root of 15. This just keeps going, okay? We can't have a square root on the denominator, so we have to rationalize. I'm multiplying by the square root of 15. So now I have -7 square root of 15 over 15. But we have to see it's saying second quadrant. So in the second quadrant, what is cotangent, positive or negative? So I want you to think, in the first quadrant, our x is positive and our y is positive, right? If I plot a point. In the second quadrant, I have to go negative in my x values and positive in my y values. In the third quadrant, they're both negative. In the fourth quadrant, my x values are positive and my y values are negative. So cotangent is x over y in the second quadrant. So negative divided by positive is a negative. So if you look at your answers, we had 2 to choose from. One's positive, one's negative. We're going to keep the negative because we're in the second quadrant. Let's do another one. So sine is -3/4 in the fourth quadrant, find cosine. This one's not going to take as long because if we use the Pythagorean identity, it's already cosine there. We don't have to go find cotangent. So sine is -3/4, but we want to square it. And we're finding cosine. So to solve for cosine, we're going to subtract this value. And that's -3/4. So 7/16. And we don't want cosine squared, we want cosine. So I'm going to take the square root of both sides. Now I have cosine of theta, and then I'm going to split that square root because I know the square root of 16 is 4. Okay, so I have cosine, and now it's in the fourth quadrant. So I just have to know, is it positive or negative in the fourth quadrant? So remember, cosine is under our x value. So if I go to the fourth quadrant, my x values, if I were to plot a point down there, our x would be positive. So it's a positive square root of 7/4. Okay, given sine and the angle's in the first quadrant, find the value for tangent. So I'm going to start with Pythagorean identity. Oops. Because tangent is y over x or sine over cosine. So we're going to get our values and then divide them. So sine is 7/10 squared. And now let's solve. So we're going to keep following the same pattern. I'm going to subtract that value squared to get cosine by itself. And then notice in the calculator, I just changed the numbers because it's the same solving tactic. So I have 51/100, square root both sides. Notice what keeps happening. My bottom value is always a perfect square. So I'm going to split up my square roots and get the square root of 51/10. Square root of 100 is 10. Okay, so this is cosine. This is going to go down here, and then the sine that we started with is going to go in the numerator. So tangent is sine divided by cosine. So take the numerator, multiply by the reciprocal of the denominator, and I have 7 over square root of 51. Rationalize the denominator. Sorry, these are taking a long time. So multiply by the square root of 51 on the top and bottom. And that's going to leave our denominator just 51, and our numerator 7 square roots of 51. So again, you always get a positive and a negative of your answer. We need to figure out what's going on in the first quadrant. So in the first quadrant, everything's positive. Our x values are going positive and our y values are going positive. So it's going to be positive value because y over x, both positive, stays positive. We'll do one more. This time we're given cosine and we need sine. So Pythagorean identity. This time we know cosine. So same thing, we're going to subtract whatever this value is from both sides. You don't have to simplify it first. So -3 over 14. 187 over 196. Alright. Square root both sides. I'm going to just split this already and see if I can get any values. So square root of 187 is a decimal, so I'm going to leave it. 196 though is 14. Seems to always be the denominator, doesn't it? Okay, and I'm in the second quadrant. So remember, our sine is our y value. So x and y are both positive here. But now in the second quadrant, my x's go backwards, they're negative, but my y's still go positive. So it's going to be a positive value. Square root of 187 over 14. Good luck, guys.